Okay, part 2, graphing cotangent. Again, if you have your table, it would be good to look at your table. Here's my unit circle. Cotangent in the unit circle, given an x and a y, the cotangent of that theta is going to be x over y. All right, so starting at angle 0, I'm going to do x over y, which is 1 over 0, which is undefined. Okay, and then I'm going to go to each quadrant angle, pi over 4. Again, since cotangent and tangent are reciprocal functions, they both have the same values at the pi over 4s. The only difference is going to be the quadrant angles. Those will all be switched. So I'm going to fill in my table, and I'm going to go ahead, and then I'll meet back here. Okay, I have my table filled out. You'll notice there is still a pattern. Undefined, 1, 0, negative 1, undefined, 1, 0, negative 1, undefined. And the period here is still pi. Okay. Cotangent is a little bit different in the fact that it backs up to the y-axis, where tangent is centered on the y-axis. My period is still pi, so I can go ahead and put those asymptotes there. And if I want my quarter periods, it's pi over 4. So every pi over 4 is going to be a critical point. So if I divide my whole period into 4, then I'll have critical points right here. So my first pi over 4 is going to be up at 1, pi over 2 will be 0, 3 pi over 4 will be negative 1. Okay, and so my function is going to follow this pattern right here. And I can continue left and I can continue right. So every pi over 4 is a critical point or an asymptote. So then right here I follow, that's a negative, a 0, and really once you get one whole period graphed, the rest of it's just following patterns. Okay, my domain here is going to be all reals except my first asymptote is 0, and this is a distance of pi. So I don't have to put 0 plus n pi. I can just do n times pi such that n is an element of the integers. Okay, and my range will be negative infinity to positive infinity. This is cotangent. When you compare them, it is a negative tangent function with a phase shift. So remember, tangent always has that center on the y-axis. Cotangent backs up to the y-axis. All right, so here's a function, y equals cotangent of x over 3. So again, we can talk about the frequency here is 1/3, so the period is going to be pi divided by 1/3, which gives me 3 pi. And so my quarter period is going to be 3 pi over 4. So look here at our scale, it's changed a little bit from up above, and every 2 is pi over 2, so this will be a pi over 4. And every 3 of those will be a critical point. Okay, every 3 will be a critical point. All right, now notice this 2 in front. So it used to be what was called an amplitude, but it's really just our vertical stretch. So instead of us going up to 1 and down to negative 1, we're going to go up to 2 and down to negative 2. All right, so for cotangent, recall that you have an asymptote, a high, a middle, a low. High, middle, low asymptote. So here's my asymptote. So every 3 of those I'll be at a high, a middle, and then a low. Go to my asymptote, I'll be at a high, a middle, and then a low. And connect those. And that's my graph. So if you need a pattern or a rhythm, then you have an asymptote, a high, middle, a low, and an asymptote. The rhythm for tangent would be an asymptote, a low, a middle, a high, and then another asymptote. Okay, so back to this cotangent here. Let's discuss no amplitudes, okay, only for sinusoidal, but there is a vertical stretch here of 2. There is no phase shift. We ain't got there yet. Important values. These are your important values, those critical points. You can list them or not. So that's going to be 3 pi over 4 and 2. This will be 3 pi over 2 and 0. And then we've got 9 pi over 4 and negative 2. The period here is going to be 3 pi. There is no vertical shift and there is no reflection. Okay, last but not least is finding solutions. So last module we talked about what to do when we've got an equation and we need these values. But just to go back through it, basically this is a y equals and this is a y equals. So in my graphing calculator I would do y equals tangent of x, and then I would also do y equals 3. So here I'm going to have like a bunch of tangent functions. Okay, they're going to look like this. And then I'm going to have y equals 3 here. And I want to find out those intersections. But it says I want all of the solutions between negative 2 pi and positive 2 pi. So when you go to graph, you can change your window and the x values to a negative 2 pi as your min and a max of positive 2 pi. As far as your y's, maybe you might want to look at your min to be negative 5 and your max to be 5. Okay, here cosine of x is equal to negative 1/3. Same thing, that's a y equals, that's a y equals, sorry, negative 1/3. So I would go y equals cosine of x, and y2 would be negative 1/3 in my graphing calculator. Okay, so my cosine, remember it starts at a maximum and then it goes down to a minimum and then back up here. And we want from negative 2 pi to positive 2 pi, so we'll have a couple different from here to here. And then you want to find negative 1/3. So that other line would be like somewhere right in here. Y equals negative 1/3. And so we want all of those solutions. Okay. Your homework is attached. Basically you have 3 graphing and then you've got some more calculators.